try it again and look for me now. I hope it stays connected. So the last video is lost.
Which Wi-Fi are you connected to? You know.
I want to say the guest net because it usually has the least traffic. That's what I think I put in here. But maybe others have discovered my secret. Don't tell anybody. Okay. What'd you get, everybody, for this ratio? Divide it out. You get there, Rhea?
About 25/14.
Oh, yeah, but I want like a number. Divide those two.
Okay, I thought you wanted a ratio. Then it would be 1.79.
Okay, let's call it 1.8. Okay. So I hope everybody got about the same thing, 1.8. Here's the cool thing. You ready? So what you found is it's a ratio 1.8 to 1. Why? Because I can always put anything over 1. So, for example, take 1.8 moles of what? Just so I know you're following. And add it to 1 mole of what? Take 1.8 moles, Aaron, of? No, careful. I want the ratio at the top to the top, the bottom to the bottom.
Oh, so you have to cross multiply?
No. We're not solving. We've got a ratio already.
1.8 HB.
Okay, good. And for us, oh man, I'm sorry. I didn't mean to put HB. It's what? Moles of NH4 plus. Remember? Because that's the one we decided we're using. Sorry about that. Okay, and add it to how many moles of NH3? Rhea? 1. And add some distilled water. How much do you want? How much distilled water should I put in there? Give me a nice number. How about no B? How much should I make up?
And nice number.
A nice number.
1,000 mil, a liter.
A liter. How nice. Add to 1.0 liters of distilled water. Stir. Stir. Done. Isn't that kind of cool? So look, our pKa, if we did that, would not be exactly 9, but we can tweak it. How? By taking a ratio of 1.8 of the acid to 1 of the base. Add any amount of that. I could double it. I could do 3.6 and 2. I could do 0.9 and 0.5. You know what I mean? Any amounts, throw it in a liter or however much you want. And then you've got a buffer system with exactly a pH of 9. That is really a lovely skill to have. Questions from you? Yes, no?
No.
Okay. You're just in awe and
Yeah.
speechless at this point, right? Good. Okay.
Can you also do with KB? Like if you're given the concentration of OH minus?
Good question. So the question is, could I do it with KB? Yes. I doubt they'll do that too, but what you'd have to do is know that the Ka plus Kb add up to make 14. And then I'd have to solve from the Kab to get the Ka. Yes, you could do it. So theoretically, you sure could. Yeah. But bear in mind, I always need to have Shopa at the end of the day to make my buffer a weak acid and its conjugate base. And if you had enough Kab, blah, blah, blah information to get that, you'd be able to make it. No.
When did they decide to use pH over pOH? Because someone made that decision at some point. So everyone only knows pH.
I bet it has to do with food. Do you remember this part of the chapter? What is most of the stuff humans eat? Acidic or basic? Maybe you guys know, Snooper people. Most of the things you eat, are they actually acidic or basic? The answer might surprise you. Tom?
Acidic.
They're acidic. So the pH scale, I don't know that, but it could be that it had to do with those stuff we use and make. And everybody said, well, there's some basic stuff, but there's an awful lot of acidic stuff in our lives, right? including in our own stomach, right? We have stomach acid and so on. So I don't know that, but I can make up stories anyway. Okay. Last little thing of buffers, and then we're going to switch to titration, which is the last part of chapter 6.
Oh, what's the buffer? The buffer? I don't know what to use.
Okay. My AP folks, you run across a young chemist in the lab and they're in a panic because they forgot to order the NH4 plus. All they have in the lab is NH3 and a lot of other strong acids and bases, and you're here to make them feel better. Okay, so here we go. They want to make a buffer, just a regular old 1-to-1 buffer, okay? So 1-to-1 buffer. We're not talking about the 1.81, nothing hard. They want to make a 1-to-1 buffer. And all they got is NH3 plus a lot of other chemicals. How could you help them? Hint, they've only got the conjugate base. You got an idea? No?
You add water.
Water wouldn't do it because this is a weak base, and it would all I would get is OH minus if I added the weak base to water. Not so helpful. But I've got all the other strong acids, hint, and bases that are in the lab.
Oh,
What
so
can I add? I want to make some kind of, I need NH4 pluses. How could I make them? Back to
you
no?
could add a strong acid.
Add a strong acid. Lovely. Okay, so you ready? Give me a here, Schnupper people. What's a strong acid that you studied in probably in 9th grade? Probably the only one you remember.
Sulfuric acid.
Sulfuric acid, that's a good one. That's strong. But it's got 2 H pluses, so that's kind of complicated, Daniel. I want one that's a little bit easier. This one's in your stomach. Yes, thank you. Super. So let's add HCl. Now, hydrochloric acid. Now, AP people, I know I can throw out the spectator here, which is Cl minus. So you know what? Can I just say I'm adding H plus? Beautiful. And now let's go ahead and make some NH. You guys are good. Your brains are all warmed up. I can tell now. Now let's see how to do it. This is the coolest part. You ready? Okay, how much? What if I give you like 0.2 moles of this stuff? Well, how can I turn this to a buffer? How much acid would I have to make so I could get a 1-to-1 of some base and some acid? So how much would I want to convert over to NH4 plus, so to speak? Back to Noah.
You want to get 0.2 moles of NH4 plus.
No, because then I'd have only NH4 plus, and I wouldn't have any NH3 left.
Oh. Do you want to make 0.1?
Yeah, why? Somebody else? Why do I want to add 0.1 moles of the strong acid? Aaron?
So you can have a 1-to-1 buffer.
Yeah, you got it, because right now I got 0 of this. Once I add that, it's kind of like an ice table, isn't it? Then I got how much left of this stuff? 0.1 moles left of that. And whoops, I added another 0 there. and I got none of the H plus left, and I got 0.1, well, let's add a 0 for fun, of NH4 plus. So, ta-da, you've saved the day. Now you have a what? A 1-to-1 ratio of NH3 to NH4 plus. So, moral of the story is, to build a buffer, I don't necessarily have to have both parts, but I have to be able to manufacture them in a simple lab. And you've got all the strong acids and bases that you need, even in our school lab, to be able to do that. So that's cool. I only need part of the buffer. I can make the other part. Beauty. Okay. Finally, that's enough buffers. Questions before we move on to buffers? Ah, he's returned. So Quinn says he would just bully them to do what they're supposed to do. Yes, and I didn't see that, but you're right. Nitric or hydrochloric, Quinn would have done it. I didn't notice you were back, Quinn. Welcome back. So we're not done with buffers unless you have any other buffer jokes or buffer questions or buffer philosophies or buffer house pets, or I don't know what you have. Okay, so let's go to our last part of chapter 6, titrations. AP people, you've done this before in an earlier chapter, but it's been a while. Schnupper people, you probably have not done this. Titrations use this, and we'll see if Quinn has done this. So this is a burette, and you can imagine it filled with either a strong acid or strong base, or some sort of acid or base, okay? It's really, really accurate. And they're really expensive too, so I'm trying to be real careful with it. So next time on Thursday, I'm going to show, sorry, Schnupper people, I'm going to show my AP folks what happens when I have bubbles in this and why that's a problem, but why you can work it out mathematically, what the effect is of that. So how to get rid of the bubbles and how to read this sucker as well. Ultimately, we're going to get to a lab, but it'll probably be after the 8th grade ski trip. I don't see me getting to it Thursday because we still need to be able to understand titrations before we could do any lab on them. Okay. Just before we go, let's write what the heck a titration is. So it's adding an acid to a base, or vice versa. Usually, with a present. We used one that was universal last time. Usually you want a present. Sarah? Thank you. Like Schnupper people, you probably use universal indicator in your 9th or 10th grades. So adding an acid to a base or vice versa with an indicator present to find an unknown concentration. Can I tell AP people where we're going? It's the formula that I love that Sherry hates. M1V equals. Now, instead of 1 and 2, guess what we can put? M acid, V, see where we're going? Equals M base times V. That's where we're headed next time. Thanks for joining us, Schnupper people. Enjoy the rest of your day. Thank you, Quinn. We'll continue with titration on Thursday.